And 9.2 velocity time graph. In here, the time equals 0. This is seconds, all 5 second, 10 second, 15 second, 20, 25, 30, 35, 40. So we are going to get the speed of car in those points. A person, few people will check in the times. A person, B person, C, D, E, F, G, H, I. They are in the road and they will get the readings. So we know that at starting point, this is going to be the velocity. We are getting the velocity. So velocity is 0. So V meter per second. And in here it is going to be 10 meter per second, 20 meter per second, 30 meter per second, 30 meter per second, then 30 meter per second, then 20 meter per second, and this is 10 meter per second and 0 meter per second. Now we'll draw the graph t versus velocity. 5, 10, 15, 20, 25, 30, 35, 40, roughly 0, and 10, 20, 30. So at A point, it is 0, time 0, and when it is after 5 seconds, we will read that it is 10. Then after another 10, then the 5 seconds, which is 10, we read it is 20. And when it is 50, it is 30. So up to here, it's like this. And then from 15 to 20, it is still 30. And 25 also, still 30. So still 30 here. And after that, then it will, when it is to 30, we will see that it is 20. And then 35 it is 10. And now it is, when it is 40, the car is stopped. So in your speedometer, you can see 0, after 5 seconds, 10, then 20, and 30, 30, 30, the same. And then apply the brake and come to 0 by 40. So this is the graph for that journey. So this is time and the velocity. Do you think that this car came back to the starting point because the graph it come back to 0? Yeah. Velocity is 0, but you can go from this place to and stop somewhere. You starting and you speed up and constant speed and you stop. There is no sign to come back. In S and T graph, distance and time, displacement, yes, when you go like that, when you come, you know that displacement is 0. But this is not displacement and time graph. So if it is come up to here, it doesn't mean that you come back. So usually you go in, stop somewhere in the same direction for this journey. In a velocity graph, how do you know that the car is going to come back? Then the direction has to be changed. So then the direction has to be changed. If it's go there and stop after 40, and if we return, direction has to be then. Then the graph has to be go like this. Because this is positive, this is negative. Now, if it is comeback journey, if we want to mark, then it is going to be a negative returning journey. Now, in a displacement time graph, let's say the time graph. So, if you draw like this, so this is the distance, and rate of change. So, what is the rate of change of displacement time graph? It is velocity. So in other way, the gradient, what is the rate of change or the gradient? So gradient imply velocity. So I discuss if it is come like this has to be a point radians or ds over dt last time. Now in this graph, velocity and time graph, what is the rate of change now? Or rate of change or gradient. In this graph, rate of change or gradient inflow velocity. In this graph, rate of change or velocity, uh, rate of change or gradient. The gradient of this graph imply what? Imply the acceleration. So if we find the gradient and that gradient is acceleration, okay, what is the acceleration for this graph? This because acceleration of a point, but we can see that the gradient of this point is equal to gradient of this point because when you draw that because it is in a line, it is not in a curve, it is not in a curve, it is in a line. So because of that, we know that the each and every point the gradient is same because we know this is y equal mx line. In a line, gradient is same everywhere. So what is the gradient? Okay, this distance is this coordinate is 1530 and this is 0 0, then y1 minus change in y over change in x, 30 minus 0, this is the y coordinate, and the x coordinate 15 minus 0, 30 divided by 15, that is 2. The gradient is 2. So the acceleration is 2. For this journey, let's say A to B, so up to here. So from here to here, there is acceleration. That acceleration is 2. Then from this to here, so what is the acceleration? What is the gradient of this one? Gradient is 0. Uh, m is minus 2. Now from here to here, gradient is 0. It is parallel to x-axis. So this is A to D journey. D. So D to F journey, then F to I journey. So this is A to D acceleration is 2. If I draw acceleration graph, so it is 15. Right? After 15, it is constant like this. So this is time and this is acceleration A. And from D to F, acceleration is 0 because gradient is 0. You know that when you drive a car, if you see a driving a car with somebody, um, when we accelerate, it will take the speed, and if we want to maintain that speed, we don't move the accelerate lower or uh, more or less. We will keep in the same angle. As a result, we are getting the same number. So this is the feeling of it. So, but mathematically, you can find in a V and T graph. If you find the gradient is 0. Then F to T journey. So 15 to 25, 15, 20, 25. This is the graph. Acceleration is 0. This is 2 and then 0 and then the deceleration. Or if you find the gradient of this one, you will see that this is a y equal mx equation, but it has a negative gradient. So we know that negative value is going to be 2. So the gradient is going to be minus 2. This is y equal 2x here as a equation. Y equal 2x, this one. This is what? This is y equal 30, always fixed. This is y equal minus 2x. Because gradient, if you see, is still the same angle. You can see when you find change in y or change in x. By the way, you know how to find the gradient of this line. So that you will get minus 2. So acceleration is negative 2. So what is the word for this one? If you remove the negative, deceleration is 2. Acceleration is negative. If you want to take the minus out, you can use deceleration is 2. That is where you apply the brake. Now how do we mark in this acceleration time graph? Negative 2, this is positive 2. Negative 2 is here. 25 to 40. Negative 2 is here. So this is the acceleration graph. What will happen up to D if goes at different speeds? So you can see here, let's say 10 and then 13 and then actually let me say 8, 13 and this is 30. So it will take a different, so these are not now uniform, I mean constant speed, constant velocity. Then the only way we can find, if we need to find acceleration, so like this one, so they have to give a equation v in terms of kind of a, so this is a quadratic curve, so 2t square plus t, or let's say 2t square plus t plus 8, something like that. Then you will find dv over dt. You get the first derivative, 4t plus 1, something like that. So then you have to put t equals 0 and you can find the acceleration of particular point. But in this case, the acceleration is constant. What is the model for constant model? Linear model, y equal mx. If it is not a linear model, then the possibility is quadratic. Then they have to give. So you may work this kind of sum, year 1 or year 2 somewhere. So when the velocity is given, then ask what is the, find the distance, acceleration. Sometimes they will give in like this, displacement and time. For example, this one, they will give s equal 2t square plus 4t plus 6. Now the question is, when t equal to, find the velocity and find the acceleration. How do you do now? They will give this curve now. So then what is the rate of change? That is velocity. So you want to find the gradient. So gradient, how do you find a gradient for this kind of curve? ds over dt. So now this is the velocity, that is 2t plus 4. Now you can find the when t equal to, you can find the value. Okay, we'll find 20 equal to 2 times 2, 4 plus 4, 8. So v is 8. Now the next question, find the velocity. Now acceleration. Then we know that now we have v and t curve. So we want to get the rate of change of velocity and time. It means now this is velocity and time. So s and t is this one, 2t square plus 4t plus 6. Now velocity and time model is what? 2t plus 4. Now how do you take the acceleration from it? Then you want to differentiate this one again. So this is going to be v equal to t plus 4 here. Then you want to get dv over dt. So that is going to be 2. So when t equal to, the acceleration is 2 because it has a constant acceleration. In terms of s, so dv over dt mean what? D square over dx square. In terms of s, this is a double differentiation for s, but for v it is a single differentiation, that is 2. dv over dt 2, or it is a double differentiation with s, ds square over second derivative dt square. Another thing is, we should know in this velocity time graph, what is the multiplication of v and t? I multiply v and t. So this is going to be distance, displacement. How do you find velocity? Velocity is displacement divided by time. Velocity v equal displacement d divided by time, or let's say s. Usual displacement we put s. Then this s When you multiply those together, SC equal VT. So then S is the displacement. So V is a one dimension, T is another dimension. X-axis, Y-axis. When you multiply two dimension, what do you get? It means this is V in a box, length multiplied by width. Or when you multiply two dimensions, what you get? Area. If you multiply by area with 1D, you will get volume. Or the same thing, 1D you multiply by 3 times, you will get volume. So 1D multiply by 2 times area. So now this is V is 1D, T is 1D, and when you multiply, you will get the area. So area of the journey or the distance, this area will give the distance. This in here, distance and displacement going to be same, not always. So distance is no, it is always the distance is you can get the area of the graph. So area is the distance. So what is the distance for this journey? So it's going to be distance is area of ADFT. So this is a trapezium. Half a, this distance is 40 and this distance is 10 and perpendicular height is 30 multiplied by 30. So 50 times 30 divided by 750. Uh, Velocity is 0, objective is stationary. Velocity is unchanged, then moving with the constant velocity, and the acceleration is 0. Velocity is increasing at a constant rate, then the acceleration is constant, where the gradient is same. And acceleration is the rate of change of a velocity. It is the gradient. It is the gradient of velocity time graph. Yeah, velocity time graph. If you find the gradient, it is the acceleration. The area between the velocity time graph and the horizontal axis. So area between, this is the graph. Velocity time graph is this one, and the horizontal axis this one, and the area is the distance traveled. Example 2. The figure shows the velocity of a graph illustrates the cyclist moving along a straight line road. This is the 12 second, and with the constant speed, and he is stopped here. And find the displacement starting point of the, so displacement is this, mean the area area of the graph equal distance. So you can find area. This is 6 times this is 8 plus this is a triangle, half a times perpendicular height, base is 4. 48 plus 12, 50, mm, 60 meter. And part B, the acceleration of the gradient of the slope. So it means deceleration we want to find. We can work two ways. If we take the coordinate 8 and 6 and 12 and 0, we will get answer straight. So 6 minus 0 over 8 minus 12, that is 6 over minus 4, that is minus 3 over 2 minus 1.8 ms2. Or if you decide to by looking at by observation, so a equal this distance is size, this distance is 4, then you have to put a negative value because this is negative gradient, so this is minus 3 over 2 minus 1.5 ms minus 2. So what is the acceleration is minus 1.5 ms minus 2. What is the deceleration? Deceleration is deceleration is 1.5 ms minus 2. According to the question, you need to answer. If it is acceleration form with the negative, deceleration without negative. Example 3. The particle is moving accelerate uniformly. Accelerate uniformly. This is a word that means constant acceleration. If you take the gradient of this point or gradient of this point is same, constant. So it is uniform acceleration. So deceleration uniformly. Deceleration uniformly. It means again constant deceleration. Constant deceleration. And in this question, part A is sketch and part B is this area is given 600 meters. We need to find the value T. So we can do that the trapezium law. Area is half a times perpendicular height 8. This distance is 60 plus 40 plus this distance is 5t, and distance equal area equal 600 given. Then 600 equal or this one half a times 8, 60 plus 40 plus 5t equals 600. It means 60 plus 5t 11t plus 40 equal, this is value is 4. 8 divided by 2 4 divided by 600 150. So 11t equal 150 minus 40, so 11t equal 110, so t equal 10.